Yeah, so stand over here. You don't want to stand back here. Just watch out. All right, so and then you want to put on goggles just in case. Definitely wear goggles. So get your goggles. All right, so let's start off with, so we're going to do this series, right? So I promised lithium, sodium, potassium. I said potassium's our limit in air. And so we'll start off with the mildest one. Let me get a slightly smaller piece. And so I'll show you in a second. Oh, it's lithium. So lithium is the hardest to cut. I don't know if you could tell that I was struggling. I don't know why it seems to be reacting. So you can see metal, right? Lithium, shiny. It looks shiny. I'll hold it up to the camera since I'm also trying to record this. We'll see how it comes out. So shiny metal. So, oh, before I drop it in, so I have just water here. Because again, we said water reactive. But I'm also going to add to it some phenolphthalein. Because remember I said, okay, these things form a hydroxide salt. And so the phenolphthalein is going to turn pink in the presence of hydroxide. So then you'll get to see that as well, that yes, we are forming hydroxide. And so you can see the pink from the phenolphthalein. We'll see if it lights up. So lithium's the mildest, right? It's just kind of fizzing. And then, of course, hydrogen gas being evolved. So if it smells a little, some people don't like the smell of hydrogen. So just kind of keep that in mind if it smells offensive to you. All right, so now let's try the next one. So going down the line. So now let's do sodium. And so again, all these are stored. I can kind of show you. They're stored under that mineral oil or terrafilm. There's some sort of oil, because again, you have to keep them away really from the water. So obviously, oil and water not miscible. And so let me just show you the sodium before we cut it. I'll show the camera too. And so you can see it's kind of poopy looking, I would call it. It's got all these white metal oxides. So it's kind of whitish looking, right? Kind of doesn't really look like a metal. So yeah, even with the parafilm, it still has a tendency to oxidize. So let's cut it fresh and see it. So now sodium's easier to cut. Let me cut a slightly smaller piece just because last year I accidentally blew it into the ceiling. Trying not to repeat that. Oops, don't want to do that either. And so now we can appreciate, I'll come around again with a fresh cut. I'll try to show the camera. So trying to show it's shinier now. If we can see that. And then I'll come around and show all of y'all. So right now that's freshly cut, nice and shiny. So that kind of matches right what we said about the alkali metals. They're shiny, they're metal. So there it is hiding under all those oxides. So now let's put it in. And so notice, right, sodium makes this little ball. And there it goes. A little sparky. Oh, one jumped out. So let me put that back. Uh-oh. Finish reacting that. And so we'll see this kind of next week as well. So I don't know how well you saw that, but
How is the sodium different from the regular table salt?
well, table salt is sodium chloride, right? So that's the product of the reaction. I mean, technically you could take pure sodium like this and mix it with chlorine gas. I wouldn't suggest ever trying that, right? Two very toxic things. But yeah, that's how you make table salt. And then, so what I wanted to mention, so did you see the orange flame? And so that should match with your flame test results that you're going to get next week. So we saw that, right, once we add energy, and we'll kind of get into that. So those electrons are being promoted, they relax back down, and then we see this characteristic orange color for sodium.
Why doesn't the sodium react with the
Well, it's just reacting with the water. So that's all that's in there. And then there's like some extra hydroxide, but that's not really going to influence anything because it's just the water that's driving it. All right, so now for the last one. So we have potassium. And a lot of people don't like to work with potassium. It's a huge hazard. The only reason why we have it is because this is something that I worked with in my PhD, so I'm familiar with it, but otherwise you have to be careful with potassium. So this one cut pretty easily. I'll come around and show you. So nice, shiny, right? Again, freshly cut. And these ones aren't too bad. You can kind of appreciate the oxide layer. I've seen some other samples that we had at RCC that were like, almost look like 50% of oxides, which are kind of scary. Let me make this a little smaller. So let's start with this amount. All right, so now let's do potassium. Again, I'll hold it. Forgot to show the camera. Again, shiny metal once it's cut. And you should kind of see a purplish flame. Here, I'll do that again. I just didn't want to overload it because potassium's fast. So let's do another little piece so you can see that. Again, try to see the purple flames. Pretty fast reaction, right? As soon as it hits that water, it's consumed. And I'll do the last little bit just so we can see that potassium. All right, so that's our demo. And so like I said, right after that is rubidium. So you'll have to go to YouTube and watch somebody like smash an ampule open as it, drops into the water, show the crazy things like that. All right, sweet, you can go back to lab, and I will stop this little demo video.